So today we're going to look at an exponential formula. So where n is in the exponent, but it's going to be related to money. So we're going to talk about compound interest. Interest that's compounded is when interest is added in. So if you're investing money, after you're paid the first set of interest, for the next period of time, you get to make interest on that interest, not just on the money you invested. Similarly, if you owe money, you end up paying more interest because you pay interest on top of the interest. So that's what compound means, is when the interest is rolled into either the investment or the debt. So the formula is A equals P times 1 plus I, all to the exponent n. So the bracket has to be around 1 plus I. In this formula, A represents the final amount of the investment, P represents the principal or the beginning amount, I is the interest rate per conversion period, and I'm going to talk about that because interest rates are always quoted per year, but then they compound at a certain time interval each year. So it could be annually or once a year, semi-annually or twice a year, quarterly, which would be 4 times a year, monthly, 12 times a year. So any time you're given an interest rate, you're also going to be told how often it's compounded or added into the investment or the debt. And the exponent n doesn't represent necessarily the number of years. It represents the number of total conversion periods. So how many times the interest is converted and added into whatever you're speaking about, an investment or a debt. So I'm going to do some examples, talk about how to calculate I and n, and how to work with this formula. We're going to be using the exponent key that we talked about in class over the last 2 days that I helped some people find on their calculator on Friday. So question number 1, $5,000 is invested at 5.25% per annum. That's just Latin for each year, but compounded annually. How much will it be worth? So how much will it be worth in 20 years? Will it be worth? So my formula is A equals P, 1 plus I to the n. P is the principal or the starting amount, which in this case is 5,000. Now, I is the interest rate per conversion period. The first thing we're going to do is take the percent and convert it to a number or a decimal, because it's not 525%. And if I just remove the percent sign and put it in as 5.25, I'm doing it as more than 100%. So I move the decimal back 2 places or divide by 100. That's how we change percents into decimals. Now I have to divide it by the frequency at which it's compounding. In this case, annually means once a year. So technically I divide it by 1. It doesn't do anything, but if the conversion time period is anything other than annually, this is going to change the value for I. But because it's 5.25% once a year, each period has 0.0525%. N is the total number of conversion periods. The investment goes for 20 years, and it's being converted once a year. Again, with annually, it seems kind of silly to do the divided by 1 and times 1 because it doesn't change. But when we do other time periods, it's going to be the same method where we divide by the number to get our rate per conversion period, and we multiply our time by the number to get our exponent n. So now I'm going to come back over here and just fill in everything into the formula. So P is 5,000. I get 1 plus 0.0525. It's always going to end up being 1 decimal, whatever your rate is. So you can do the 1 plus if you want to, but I know 1 plus 0.0525 is just going to be 1.0525. In my exponent, it's 20. So now it's just a matter of typing it into your calculator. On my calculator, my exponent is the little TP thing or the hat, which we talked about, and I can type it in as I see it. So 5,000 times 1.0525 to the exponent 20, and I get my answer. Now, because it's money, I'm always going to round to 2 decimal places or the nearest hundredth or penny. So in this case, the $5,000 will grow to $13,912.72. So I'm not going to write out all the words, but question number 2 is $18,000 invested at 8% per annum. That's what the /A is. That just means per year. compounded semi-annually for a total term of 4 years. And we're going to figure out how much the investment will be worth and how much interest is going to be made. Now, here's where I have to be careful. Semi-annually means twice a year or every 6 months. If I do 8% every 6 months, that would actually give me 16% in a year, and that's not equal to 8% per annum. So when I calculate my I value, I have to change 8% to a decimal, so it's 0.08, and then I'm going to divide by 2 because semi-annually means twice a year. So in this case, my I value is actually 0.04. 4% every 6 months will equal 8% over the year. Total number of conversion periods, it's 4 years, but the interest is being converted twice every year or every 6 months. So now I'm going to multiply by 2, and that's going to give me 8. So my I value is going to be 0.04. My N value is going to be 8. My P is 18,000, and I'm going to go to my formula. So it's going to be 18,000. 1 plus I is just going to be 1.04, and my exponent is going to be 8. Now I just type it into my calculator, and it's $24,634.24. And now to figure out the amount of interest, and the dollar amount for interest is usually represented with a capital I, is just how much of this is extra money. I put in the $18,000, so $18,000 of it was mine. Now it's worth $24,634.24. So if I take off the $18,000 that was my money, that gives me $6,634.24 is interest. Interest is always extra. Extra money you get or extra money you pay. So now I have $500 at 6% per annum, compounded monthly for 15 years. So monthly means 12 times a year. So to calculate my I change my 6% to a decimal, which is 0.06. Now I'm going to divide it by 12, 0.005. My N is 15 years, but now I have to multiply it by 12. So it's 180. And my P is 500. I go to my formula. And the exponent is large, but that's what my calculator is for. So I typed in the wrong interest. So I'm just redoing it. That's better. So $1,227.05 if I round to 2 decimal places. And again, if they ask for how much interest, I just subtract my original $500 off. So in this case, the interest would be $727.05. Okay, a little bit different. You want to have $10,000 in 8 years for down payment on a house. How much would you have to invest today at 5% per annum, compounded quarterly? So to save $10,000 in 8 years, if we can invest in an account that makes 5% per annum compounded quarterly, we're now looking for principal. So if I go to my original formula, A equals P times 1 plus I to the N, P is what I'm looking for. So I'm going to isolate P by saying, okay, on this side, the 1 plus I to the N is multiplying my P. If I want to isolate P, I'm going to bring that bracket to the other side and divide it. And it's fine to work with this formula. But if you think back to grades 9 and 10, You should have talked about negative exponents. When you have division with exponents, that's the same as having a negative exponent. So a divided by 1 plus I to the n is really the same as a times 1 plus I to the negative n. And because I'm going to use my calculator with the negative exponent, it's just a matter of typing it in. So these are very similar formulas, just when I'm looking for a and I know p, I'm multiplying by the 1 plus I to the n. When I'm looking for p and I know a, I'm dividing by 1 plus I to the n, and negative exponents mean division, so that I can just add the negative to the formula. So in this case, my final amount is going to be 18,000. My I is going to be 5% divided by 4, because quarterly means 4 times every year. And that should give me 0.0125. I'm just going to double check that. Yep. And my N is going to be 8 years times 4, because the interest is converting 4 times every year. So over 8 years, that gives me a total of 32 conversion periods. And now I'm just going to sub into this formula to solve for P. So I'm going to do 18,000, 1.0125, because it's 1 plus I. So it's always going to put a 1 in front of the decimal that represents my I value. And in this case, it's negative 32, because I'm dividing. My principal should always be lower than my final amount. And I'm going to type it in just like I did before. The only difference is now I'm putting it in with a negative exponent. So to the exponent negative 32. And it's $12,095.71. So that represents how much I would have to invest. If I wanted to find the interest I was making for this one, I would take my 18,000, subtract 12,095.71 is going to be $5,904.29. So that's how much extra money there is. I put in just over 12,000, and I get just about 6,000 to get the 18,000. So what I would like you to do in your textbooks is, starting on page 70, number 1, 2, 4, and 5. From each of these, I just want you to do A and C. There's a whole bunch to practice. You can do more if you want to, but for these first 4 questions, you really just need to do 2 out of each to practice just with finding I and starting with the formula, and then take a look at questions 8, 9, 10, 14, and 16. There are more single questions like the examples I did, so you don't have to worry about just doing parts. I'd like you to do all of those.